And we're back for a second day of parametric equations. The three objectives here are what we will be discussing today. And really that second objective, graphing parametric equations, you're going to find in the worksheet instead of in the video lesson. Just like we talked about last class, you are going to complete the worksheet first. This is going to give you a lot of extra information that the video will not. Come back and watch this video if you feel like you need some additional support. Or if you want to just do a couple extra practice problems and then check your answers with my video solutions, that would be great as well. Our first example involves eliminating the parameter. So in this particular case, we want to be getting rid of this theta value that we see in our equation. That's the third variable we want. We want to keep x and y, and we want to get rid of theta. So what we need to do first is isolate the trig function. I'm going to add 1 to the other side and then divide by 3 to get cosine of theta alone. And likewise on the other side, I'm going to subtract 5 and divide by 3 to get sine of theta alone. Then we know a Pythagorean identity, cosine squared plus sine squared equals 1. And I'm going to rewrite that just in a little bit different context, just so we can see the substitution come into play. So I'm just moving the squareds to the outside. And next what I'm going to do is directly substitute in this value over here for cosine. So x plus 1 over 3. And I'll do the same thing for sine, y minus 5 over 3. Structurally, these are all still squared, and it's still equivalent to 1. Next, what I'm going to do is distribute the squareds down to both of those terms. So when I distribute, I get x plus 1 squared over 3 squared, which is 9, plus y minus 5 squared over 3 squared, which is also 9. Because these both have 9s in the denominator, I'm going to multiply that to the other side and write this as x plus 1 plus y minus 5 squared on both of them is equal to 9. This is the equation of a conic, and to be specific, it's the equation of a circle. Our second example also asks us to eliminate the parameter. So we're trying to get rid of that theta value. We're trying to get rid of this guy right here. So we only have 2 equations left. We'll do the same thing, isolate the trig function. So x plus 3 over 4 is what tangent of theta is equivalent to. And on our other side, y minus 1 over 2 is what secant of theta is equal to. The trig, or the Pythag identity that we use with tangent and secant, remember, is me plus my tan equals sexy. It works, you remember it, even though it was a couple months ago. Okay, I'm going to rewrite this just so the squareds are on the outside. We can see the substitution a little bit easier that way. And I'm going to directly substitute in this x plus 3 over 4 for tangent, and directly substitute in the y minus 1 over 2 for secant. These structures are still squared, and we still have that plus 1 at the beginning and the equal sign between them. Then, just like we did before, we're going to distribute through. So I get x plus 3 squared over 4 squared, which is 16, equal to y minus 1 squared over 2 squared, which is 4. And that's still got a plus 1 out front. Now this isn't quite a conic equation yet, so what I need to do is get this 1 all by itself. I'm going to subtract over that entire term, so I have y minus 1 squared over 4 minus that entire structure, x plus 3 squared over 16. Now, because I see that minus sign in the middle especially, I know this is in standard conic form, and I'm recognizing this to be a hyperbola.